Class 12 board appearing children, you know, term 2 exam is very close. I want to give you gist and most important concepts regarding refraction and reflection through the prism. You can see the formula 0 mu g, that is the refractive index with respect to vacuum. That is also called absolute refractive index. We ignore 0. It means when we write mu g, it means it is with respect to vacuum or air. What main concept I want to give you for this is refractive index depends upon the velocity in one medium and the other medium. This is the velocity in vacuum. This is the velocity in the given medium. Now you know this formula. You can see frequency remains the same. Frequency of a light ray never changes. It is the original property. Wavelength changes. It depends upon the nature of the medium. Here, this is the wavelength of the light in vacuum. But when the light ray is going into glass, its wavelength is lambda g. Wavelength has changed. Frequency does not change. Many questions come over this concept only in the form of numerical, in the form of short questions, in the form of explanations. You can see the question may be like this. A light ray is going from vacuum to glass. The wavelength in vacuum is this much. What will be the wavelength in glass? For two given media, you know that one medium, another medium. So this will become the wavelength in first medium and this will become the wavelength in the second medium. When the light ray is going from one medium to other medium, wavelength in one medium is given, then you can find out wavelength in other medium. You have not to change the unit also. If you put the wavelength in angstrom, the wavelength will come in angstrom. This is the numeral only. It has no unit. And two most important things. Speed changes when the light ray goes from one medium to other medium. Wavelength changes, but what remains the same? Frequency remains the same. जैसे बच्चे का ड्रेस चेंज कर सकता है, उसकी लंबाई बढ़ सकती है, घट सकती है, लेकिन पेरेंट के नेम तो वही रहते हैं, चाहे वो इंडिया में हो या यूएसए में हो. सो फ्रीक्वेंसी इज लाइक पेरेंट. Speed, wavelength, they are like dresses. What the main concept I wanted to give you, frequency will not change. Wavelength will change. Speed will change depending upon the nature of the medium. What is this? This is the critical angle. Since you have read it, I am stressing upon those things which are to be given important. This is the critical angle. This is the refractive index of glass, maybe of any medium. So there is a relationship between refractive index and critical angle. For different media, critical angle will have different values. For glass, this comes out to be 41.8 degree. when you put the value of mu j, which is 1.5, you can keep it like 42 degree also. This is the critical angle. Critical. If the angle of incidence is more than critical angle, the light ray will suffer total internal reflection. If the angle of incidence in the denser medium is less than this, there will not be total internal reflection. Only refraction will take place. The basic concept behind it, total internal reflection, many concepts do come there. What are the conditions? Light rays must be going from denser to rarer medium. Angle of incidence in the denser medium must be more than critical angle. For glass, this is 42 degree or 41.8 degree. For different transparent materials, critical angles will have different values. Now, total reflecting prism. The right-angled prism acts as total reflecting prism. You can see the ray is coming here. It is getting reflected. First main concept is what? For normal incidence, there is no deviation. Angle of incidence is 0. Angle of refraction is also 0. That is, when the light ray falls perpendicularly, it does not have any deviation. So this ray has come here. This is a right angle triangle. This is 90 degree, this is 45 degree, this is 45 degree. You can see from here, this angle will come out to be 45 degree. This is normal, this is 90 degree, this is 45, this is 45. So this is also 45 degree. Now 45 degree is more than 41.8 degree. That is critical angle for glass. So it has suffered total internal reflection. That is, angle of incidence is equal to angle of reflection. So this becomes 90 degree. So it comes down. For this surface, this is falling perpendicularly. So it has no deviation. It is directly coming out. That was for one ray. Now we have taken two rays. Same thing is happening here. You can see for one ray, just now you have seen, this is coming down under the condition of total internal reflection. For other ray, it will follow the same thing. It is coming here, coming down. Now you imagine, this is the object from where rays are coming. Then after reflection, rays are going here. If you take different groups of rays coming out from A and B, they will make their images at A dash, B dash. So A dash, B dash is the image of AB, which is of the same size. It is not perfectly inverted. It has come down like this. Now the right angle triangle can be used as double reflecting. For the previous position, it was having only one deviation, one reflection. Now what you find here? This angle is 90 degree, this is 45 degree. The ray is coming here. Again the same concept, the ray is falling perpendicularly. It has no deviation, it will come here. But for this surface, this angle is 45 degree, this is 45 degree, so this becomes 45 degree. which is more than critical angle, 41.8 degree. More than, so total reflection will take place. That is angle of incidence is equal to angle of reflection. Means if this is 45 degree, this is also 45 degree. So this becomes 90 degree. It means this becomes parallel to the base. Simple figure. This is coming here, getting reflected. Again, for this position, you can see this is 90 degree, this is 45 degree. Same thing will happen here. This angle is also 45 degree. So this will become 45 degree. Total angle 90 degree. Ray will come down, reflected back on the same principle. So this ray is coming here, getting reflected once over this surface. After that, over this surface. Then coming down. Again, this is 90 degree, falling perpendicularly. So ray comes down without any deviation. For this figure, two rays are coming. One ray case you have seen. Now you have taken two rays. Same thing will happen. Only complexity in the figure does come. But you have not to get perplexed. This is one ray. Same concept without deviation coming here. Angle 45 degree. This will become 45 degree. This is 90 degree. So ray is coming here, coming down. If you take second ray, this will come here. This will come here and will come down. Now you imagine this is the object. This arrow one is the object. From head and tail, rays are coming and rays are going along this. You see this arrow part is coming on this side. So this has got inverted, not perfectly through 180 degree. This is on this side, this is on this side. You can say this is inverted. This is towards left, this is towards right. Size of the image does come the same. But the figure is more clear. This is the usage of this right-angled prism, double reflecting prism. Image of this has been formed here. You can see from symmetry or from the figure also. The size of the image remains the same. But that will happen only for this structure of the prism. It is one of the most important questions related with the prism. A ray is coming down perpendicularly over the surface of the prism. This is the refracting surface. Ray is coming perpendicularly. When the light ray comes perpendicularly, it has no deviation. Angle of incidence 0, angle of refraction will be also 0. So when the light ray comes perpendicularly, जब आप तीर चलाएंगे परपेंडिकुलरली, उसमें डेविएशन नहीं आएगा, ये सीधे पार कर जाएगा। आगे देखना है आपको कि आगे क्या होगा। तो व्हाट इज द क्वेश्चन? Will this ray suffer total internal reflection on striking the face AC? When this light ray comes over AC, whether it will have deviation under refraction or it will have total internal reflection. You have to decide. For total internal reflection, what is the condition? Angle of incidence over the surface must be more than critical angle. If the angle of incidence is more than critical angle, total internal reflection will take place. If angle of incidence is less than critical angle, total internal reflection will not take place. You can see now the answer. Mu is equal to 1 by sin C you have read. Now, Sin C is equal to 1 by W mu G. This is the relation in mu G and mu W. Lower one goes up, upper one comes down. So this is mu W by mu G. If you put those values, mu W for this is 4 by 3, mu G is 3 by 2, this is 8 by 9. So C is sine inverse 8 by 9, which is 62.73 degree, 73 degree. What happens here? Prism has been placed in water. So in using the formula mu is equal to 1 by sine C, you have to take the refractive index of glass with respect to water. So we have taken W mu G. Water is one medium from where light is going to glass, means prism. W mu G you have taken. Prism has been placed in water. Prism is of the material. What is that? That is glass. So W mu G you have taken. Since ray is going from water to glass, sin C is equal to 1 by W mu G. For this pair of media, water and glass, your critical angle comes out to be 62.73 degree. But when you see the light ray coming, that angle will come out to be 60 degree. This is the ray. This is normal. So without deviation coming over the face AC. Now you can see here, this is 90 degree, this is 60 degree, this is 30 degree. So this angle becomes 60 degree. This 60 degree is less than critical angle for this pair of media. So it will not have total internal reflection. It will get deviated. This is the original path. Very simple. Going from denser to rarer, it will go away from the normal. This is the normal. It is coming down along this. So that is the path of the ray. Without deviation, since angle of incidence 0. Normal incidence, but angle of incidence 0. Angle of refraction 0, no deviation. Coming here, for the normal over this surface, you can see this is 60 degree, which is less than critical angle. It means it will not have total internal reflection. It will have deviation. Now deviation, it is going from denser to rarer. So it will go away from the normal. It is not coming towards the normal. It is going away from the normal. So the ray is coming here. For prism, this is the most important question. Plot the graph between angle of deviation and the angle of incidence. Just I want to give you the background for this prism. You have drawn many times. This is not very much useful for your exam point of view. This is the incident ray. This is angle of incidence. Light ray is coming here after refraction, then emerging out. When you extend this line, this gives you angle of minimum deviation for certain condition. But in normal situation, you say this is the angle of deviation. This ray was coming along this path. It has got deviated along this. So this is angle of deviation. Angle of incidence, angle of refraction over first surface, second surface. This is angle of emergence. Only the background means you have drawn it many times when you have been in class 12. First part of the question is draw the graph between angle of deviation and angle of incidence or angle of emergence. When you plot this graph, angle of incidence along this line and angle of deviation along this line, you get this graph. This is the most important part. You have to plot the graph. This should be a clear one. But you can find it everywhere it has been given. This is minimum angle of deviation. From the graph also you can see, this is nothing else. From the graph, for this graph, what you find? This is the position of minimum angle of deviation. This is del m. In the beginning, what happens when you increase the angle of incidence? This decreases. It goes on decreasing. After that, it increases. It is parabolic in nature. The lower one is the minimum angle of deviation. What you write? You write, I know. This is I1 is equal to I2. Path of the light is reversible. When you take the light from left to right over the prism, in the previous figure you have seen that one. When you take the light ray from left to right, it will follow path as shown. If you reverse it, then what happens? The light ray goes from right to left on the same path. Path is reversible. And if you visualize the angle of deviation, you will find, if you plot the graph of angle of deviation for angle of incidence or angle of emergence, the graph will be of same nature. For certain angle of incidence, you can see there are two angles. For this angle of deviation, this is one I1 and this is I2. Actually, I2 is nothing but angle of emergence since path is reversible. For minimum angle of deviation, you will see I1 and I2 will become same. Corresponding to this angle of deviation, only one angle of incidence. Means angle of incidence and angle of emergence, they will become the same. So that is the graph. And you have to practice this one. You must write I1 is equal to I2. So for minimum angle of deviation, what is the condition? Angle of incidence must be equal to angle of emergence. Angle of incidence is equal to angle of emergence. So angle of refraction over the first surface must be equal to the R2, what you have taken in your figure. Means R1 must be equal to R2. So two conditions are there. Same condition. I1 is I2, R1 is R2. That is the condition for minimum angle of deviation. This is the graph. For minimum angle condition, angle of incidence and angle of emergence, they do become the same. If you use that condition, I1 is equal to I2, R1 is equal to R2, and you are going to suppose that is the angle of incidence, this is the angle of refraction. Then from prism formula, R1 plus R2 is A, angle of the prism. When they do become same, R is A by 2. If you convert this, del becomes del M. Since we are going to write for minimum angle of deviation, this is the normal formula. For minimum angle of deviation, this del is minimum angle of deviation. So you write del M plus A is equal to I plus I. Since I1 and I2 have become same. So mu is equal to sin I by sin R. If you put I, R, you get this one. So very simple. It gives even 5 marks.